Thursday, yeah. Thursday, I don't think anything happens first period. Usually first period is the overview, second and third there's drills, and fourth period's the debrief or something goofy. Okay. So, please write that essential question down for me. What are the steps for partial fraction decomposition? That looks like fun, doesn't it? This really isn't that bad. Actually, I kind of enjoy this one. And then once you've got that written down, you need to get out a box of colored pencils out of the box. Yep, we're going to use colors. It's going to make it easier to identify stuff. You like it when we color? Oh, we didn't even. I'm missing an example. All right, everybody has your essential question written while I'm fixing this up. Where is it? Notebook. One example that's not in there, apparently. My computer's being silly slow today. Okay, well, we'll get to it. All right. Let's take a look at these. So, this is a way to apply. Oh, there it is. All right, what page are we on in our notes right now? 93. 92. Okay, so I'm going to grab this last example here before we get too far so that I don't have to write it out. It is under view, I think. Nope. Edit. Nope. Document. There. Tools. Select and zoom. Snapshot. Okay. Escape. There we go. Okay. Now we're there. All right. So what we're going to do today, not only applies to, well, it's a good application of systems of equations where we use it in other pieces of algebra. Systems come up all over the place in strange things. Anytime we've got to solve for two things, we have to set up a system, okay? So we're going to do what we call writing the partial fraction decomposition of that. Basically, earlier this year, we went and we added two fractions together, okay? Well, we have to be able to take them apart somehow. So this is the process we use, and we need systems of equations to do it. All right? Where we typically see this again, and I reteach this lesson again, is in the second year of calculus. Okay? We use it in parts of that. Okay? So, let's take a look at this first one. So the first thing I'm going to do is a good old magic X. All right? So let's go with our magic X, and I'm going to do a magic X and factor that denominator. So I'm doing this just off to the side somewhere. I need two numbers that multiply to -6 and add to -1. What are they? -3 and 2. Everybody agree with that? Okay, so right underneath here, I'm going to write x minus 3 times x plus 2. I am going to rewrite this as two fractions that each have that as their denominator. So one has x minus 3 and one has x plus 2. And those could be in reversed order. Okay. Now I'm going to write a and b at the top. I got to figure out what the numerator is. It's not just x over 1 and 7 over the other. That doesn't work. Okay? So, what I'm going to do is I'm going to use some of my techniques in order to get rid of fractions, because I don't like having all those fractions that we used when we were doing rational expressions. So, I'm going to choose to multiply everything by the least common denominator, which is this thing here. So I'm going to multiply everything by x plus 3 times x plus 2. Sorry, x minus 3, not x plus 3. X minus 3 times x plus 2. And we're going to do that on each term. X minus 3, x plus 2, x minus 3, and x plus 2. Use orange. Okay, so I'm going to cross out my, everything here would cross out, right? So the only thing I'd have left would be x plus 7. What crosses out in this second fraction?
X minus 3.
Good. And I'm going to, while I'm doing this, distribute in the a. So that would give me ax plus 2a. In this third fraction, what cancels? X plus 2, and I'm going to distribute in the b. So bx minus 3b. All right, here's where the colors come in. All right, because I want you to really be able to identify this. So pick a blue. We'll do our first equation in blue. And here's what we're going to do. I want you to remember, in front of that x, there's always a 1, right? So I want you to box any number that is in front of an x. Just the coefficients of the x. Not the x itself, just the coefficients of x. And the a and the b are going to act like coefficients for a minute. Really? Okay. So do you see how I boxed a 1? I boxed an a and I boxed a b. My goal was to solve for the a and the b, which is two different variables, which means I need a systems of equations. So the first equation we write is the x equation. And I'm going to write it by writing those coefficients. So I'm going to write 1 equals a plus b. You see where I got it from? See what I boxed? And I put the equal sign. I kept the 1 on the left, kept the a and the b on the right. Okay, now let's pick on red. Because red's easy to see. Okay? And I'm going to circle everything else, all the constant terms in red. So 7, 2a, and negative 3b, circle them in red. That is going to become my second equation. So my second equation is 7 equals 2a minus 3b. All right. At this point, now do you see how we have it color-coded? We have the blue equation, and you can see where we got it from, and the red equation, and you can see where we got it from. That's the extent of the colors you need to do. Okay, I make mine really colorful because I just use colors all the time, right? You guys can go back to your regular pencil now. Okay, so now, do you see how we created a systems of equations there? So, we can use substitution, elimination, or Kramer's rule. I'd probably go elimination. I'm going to choose to eliminate the a. So I'm going to multiply this by negative 2. And I'm just going to write it underneath here because I'm being kind of lazy today. I don't want to rewrite things if I don't have to. So negative 2 times negative 2a times minus 2b. And I'm just going to add up the red equation and the purple equation. So what's 7 minus 2?
6, 5.
The a's are gone. What's negative 3b and negative 2b?
Negative 5b.
And then divide by negative 5, and what do you get? Negative 1. So I solved for b. How am I going to get a?
By plugging that in.
Which equation should I plug it into?
The one that equals 1.
Yeah, the blue one, right? So I'm going to plug into this thing here. So 1 equals a minus 1. I'm going to move the 1 over to the other side. What do we get for a? 2. Now here's how we finish the partial fraction. Okay? I need to rewrite these two things up here as fractions. Okay, so I'm going to kind of bring my work down here. So for the a, I am substituting in a 2. So 2 over x minus 3. And then for the b, we solved -1, right? So either plus -1 over x plus 2 or -1 over x plus 2. Either one would work. So this thing here is your final answer. Let me see what the ugliness is here. All right. Let's try. I'd like to be able to give you one. Oh, that one's horrible. All right. Let's try example. That one's not too bad. What's wrong, Ivan?
I just have one question.
Uh-huh.
What did you factor in the beginning of the problem?
What did I factor?
Yeah.
I factored this denominator right here.
Okay.
Okay, does that make sense?
Yeah.
All right. Okay, so here's what I'm gonna do. What's wrong?
Yeah.
What's wrong?
Why did you multiply
Why did I multiply
the -2?
this by -2? Because I wanted to cancel the a's. I was using elimination to cancel the a's. Okay? Alright, everybody, any other questions on 1? Alright. Here's what we're going to do. We're going to start this next one together, because if I try to show you the third one before we do one more of these, I don't think it's going to work out well. So, because the third one has a fraction in it. Alright, so first thing we did was what with this denominator?
Magic X.
Magic x. So I need 2 numbers that multiply to 8 and add to 6.
4 and 2.
4 and
Good. So we've got x plus 4 times x plus 2. Alright, so those 2 things become my new denominators. And we're going to write them as x plus 4 first and x plus 2 second. And again, if you write it in the reverse order, your answer is going to look slightly different, but not much. It should have this, the numerator and denominator pairs should be the same. Okay? Alright, so what was, and then I wrote an a and a b, right? And then the next step was, what did we do?
divide or multiply everything by x plus 1, x plus 2.
Yep, multiply everything x plus 4, x plus 2
By your LCD.
by your LCD. That's right. Okay. So, I'm going to cross everything out on this one, and I'm left with x plus 8, and there's a 1 in front. Alright, and then the x plus 4 cancels. I distribute the a. What do we end up with?
X plus 2.
Ax plus what? 2a, good. What cancels in the last term here?
X plus 2.
Good, and what do we do with the b?
Distribute.
Distribute, and what do we end up with?
Plus b and plus 4b.
Good. Alright, everybody box in blue the coefficients in front of the x's. Alright, let's write that equation. So, it would be 1 equals what?
A plus b.
It happened to be the same as the last one. It won't always be that way. Alright, and then in red, I'm going to circle my other equation. So what's my second equation?
A equals 2a plus 4b.
Good. Alright, from here, I want you to finish it. So solve the system that's left there. I'm going to give you a minute to do it. Everybody try it. let's check it. So what did you multiply by?
Negative 2a.
-2. So we got -2 equals -2a minus 2b. Alright, so what'd you get when you added up?
6.
Equals 2b. B equals 3. We plug into the blue one. 1 equals a plus 3, so a equals -2. And then to finish it up, we put it that we do what goes over the x plus 4? -2. And what goes over the x plus 2? 3. So not so bad. Alright, let's try it again. The next answer comes out weird. Okay, so that's why I want to make sure we do it together here. What does the how do you factor that denominator?
0.
We didn't factor anything with 0, so
X
difference of squares. There we go. Okay, so what's the square root of 4x squared?
2.
2x.
2x. What's the square root of 9?
3.
3. Make 1a and 1a negative. So I'm going to make 2x plus 3 one of them and 2x minus 3 the other one. And then we throw an a and a b on the top. Alright, what's our next step?
Divide it,
Multiply by your LCD.
Multiply by the LCD. Good. I'm going to use a different color. Cross stuff out with. Okay, so I'm going to cancel stuff out. I'm going to cancel. I'm just left with a 1 equals. What's cancels in this middle term here? Good, and I'm going to distribute the a. So watch how I write this. 2ax minus 3a. A, remember, is part of the coefficient in this context of the problem. All right, in the third term, what are we going to get rid of?
The -1.
2x minus 3. And I'm going to distribute in the b. So we get what?
2bx plus 3b.
Good. All right, look at the left side. Are there any x's?
No.
But we still need an x to set up an equation. So if there are no x's, aren't there 0 x's? So you can always put that in. If there's something missing, you can always put that in. All right. So let's go with our, what did we use first? Blue? So I'm going to box in blue my coefficients in front of my x. So my x equation would be 0 equals 2a plus 2b. Then I'm going to circle in red all the constants that are left. So I have 1 equals -3a plus 3b. All right. Do we want to do substitution or elimination? Substitution?
I don't know.
Doesn't matter. Pick one.
I don't know.
Substitution. Okay, so I'm going to solve this one here for, let's say we solve it for a. Okay? So I'm going to get the b to the other side. So I've got -2b equals 2a. And then when I divide by 2, what do we end up with?
A, -b equals a.
Yeah. So can't I take this and plug it in for the a in the other equation?
Yeah.
Make sure you're caught up. Okay, so I've got 1 equals -3 times -b for the a plus 3b. What's -3 times -b?
Positive 3b.
Plus 3b. What's 3b plus 3b?
6b.
What does b end up being?
1/6.
1/6.
Now, the good news about the way we did it with substitution is, can't I just plug into this thing here to get A?
Yeah.
And considering we ended up with a fraction, boy, substitution was probably the way to go. Alright. You're going to get to leave. I'm going to let you leave the complex fraction on this one. Okay? So all we're going to do is plug into the top of those things again. So over the 2x plus 3, we would put in negative 1/6. And then over the 2x minus 3, we would put in 1/6. So write that down. And I'm going to be okay with you leaving your answer like that. That's okay. I know we've got an ugly double fraction. It's going to be all right. So let me show you. I don't want you to freak out, but let me show you what they will possibly do with the answer. Sometimes your book might do this in the answer key. What did I do? Oops, I lost a negative, didn't I?
Yeah.
What did I pull out?
1/6.
I factored out a 1/6, right? I took out a greatest common factor. So the book answer very well might look like that. Or they might take out a negative 1/6 and flip the signs. I'm okay with this answer. All right? Perfectly okay with that. If the book goes a little further, it goes a little further. Okay? All right, we got 2 more. Getting a little bit uglier each time. All right. So, looks like we've got a leading coefficient, so we need a magic X and a box, right? So, why doesn't everybody do that part on their own? Everybody do the magic X in the box and see if you can get that factored. You should be able to do that part. And then write out your 2 factors. All right, check mine. Do you agree with it?
Yes.
Ivan does. Does anybody else?
Yeah.
Yeah, we all okay?
Yeah.
All right, so I'm not going to go over the factoring piece. Let's just go over the rest of it. So I'm going to multiply by my least common denominator, so 2x minus 1 times 2x minus 1, x plus 2 times 2x minus 1. Is it possible you did these in the other order?
Yeah.
That's okay. All right, it should turn out similar in the end. All right, so we're going to cross these out. I'm left with 5x minus 10 equals. In the a term, what's going to cross out?
X plus 2.
And we're going to do what with the a?
Distribute.
So 2ax minus 2a.
Isn't it
1.
Oh, sorry, 1a. Thank you. I don't know why I'm putting a 2. This would be the... Mrs. Ballard didn't get enough sleep last night. All right. What crosses out in this one here?
2x.
Good. And we're going to distribute the b. So bx plus 2b. All right, let's get out the blue and the red again. So blue is going to be boxed. So I'm going to box my in front of my x's. So I set up an equation that's 5 equals 2a plus b. And then red is going to be my constants. So I've got negative 10, negative a, and 2b. So negative 10 equals negative a plus 2b. Okay. So, I'd probably go elimination. What do you want to eliminate, the A's or the B's? I heard B's first, so I'm going to multiply this one, right? If I'm going to do B's, I need to multiply by -2, and I'm just going to rewrite both of them that direction. So -10 equals -4a minus 2b. Did I do it right?
Yeah.
I'm just rewriting this one. I'm not... I guess I could have written underneath. Oops, B. Okay, so what's -10 and -10?
-10.
Zero.
-4a and a.
-5.
Negative.
Wouldn't it be negative?
Negative. What happened? Something's over.
-3a.
It's -a. There we go.
There we go.
-5a. You were right. I had the wrong stuff down there. Wasn't going to work out very well otherwise. Alright, the B's are gone. So what is a equal to? 4. Good. Alright, do we want to go into the blue equation or the red equation? The top one, the blue one. So 5 equals 2 times 4 plus b. What's 2 times 4?
8.
8. And then I'm going to move the 8 to the other side. And what do we end up with? -3 equals b. Alright, so we've got over the x plus 2, what are you going to put? 4. And over the 2x minus 1, what are you going to put? -3. And again, it could be a reverse order of that. You could have -3 over 2x minus 1 plus 4 over x plus 2. Alright, we're going to do one more. Get just enough time for it here. Okay. The next one is going to be a little, we're going to go one little step further here. Okay. See how there's 3 terms? Yeah, so we could do this with 3. Alright. We don't tend to see the 3 in AP Calc, but it comes up in your book, so that's why we're showing it to you. Let's think about what this is here. Okay, so I could factor out an x, couldn't I? What's left behind?
X squared minus 9.
Good. Can't I do a difference of squares on that?
Yeah.
And I'm being really sloppy by putting it underneath, but I don't want to rewrite a million times. So x plus 3x minus 3. Do you see how those 3 things can now become the denominators?
Yep.
So now I have A, B, and C.
C.
And since we know how to solve a system of 3, we can do that. Okay? So, we're going to try this. Let's see what happens. So, I'm going to multiply everything by the LCD. So, x times x plus 3 times x minus 3. X times... Let's think about this. Let's work smart and not hard on this one. The x is what's going to cancel, isn't it? Isn't x plus 3 times x minus 3 just x squared minus 9? Couldn't I write that instead? X. Why would I write that? Because I would have to, when I'm distributing the A, I'd have to FOIL those back together.
Oh, yeah.
Okay, so I already know what it is, don't I? Because I did it in the process. X, that's really awful. I can't write it. I gotta write it smaller. Sorry. Fix that up. So x times x plus 3 times x minus 3. I don't think I made it any better. Okay. So everything in the first one cancels, right? So we're left with 1x squared plus 12x minus 9.
Whoa.
In this second term, we know the x's cancel and I'm distributing in the a. So I get ax squared minus 9a. What's going to cancel in this third term?
X plus 3.
Good. And I'm distributing in bx. So what's bx times x?
Dx.
Bx squared. What's bx times negative 3?
3bx.
Negative 3bx. Good. In the C term, what cancels? X minus 3, and I'm distributing in cx. So what's cx times x?
C
cx times 3.
3C
3cx. Okay. We did our blue pencil first, right? So in blue, I'm going to box everything in front of a squared.
Yep.
So my equation would be 1 equals a plus b plus c. All right, I'm going to get out my red pencil and I'm going to circle everything that has an x in front, or is in front of just an x. So we've got 12 equals negative 3b, it's plus 3c, right? Plus 3c.
Wouldn't it also be, wouldn't you also circle minus 9a?
It doesn't have an x after it.
Oh.
Okay. All right, pick another color. Your choice. I'm going to go with green. All right, I'm going to put a triangle around it. Triangle around the negative 9 and the negative 9a, right? Because there's a third equation. I've got 3 variables. I need 3 equations. So negative 9 equals negative 9a. Good news. I get to use back substitution, don't I? Sort of good news. All right, so I could solve for a pretty easily, can't I? So when I get, how do I move the 9 to the other side? Divide, what do we end up with? 1. I'd probably go ahead and sub that into this top equation, right? So we get 1 equals 1 plus b plus c. So what's b plus c equal to? 0, because we got to subtract the 1. All right, so look at what we're looking at now. To solve for b and c. Oh, don't highlight it in purple. That would be bad. We wouldn't be able to read it. Let's go yellow. All right, so we're looking at this equation and this equation to get combined to maybe use elimination on. So I'm looking at probably using this, multiplying this one. What would we multiply it by? Can I just use 3? So let's see, I've got 0 equals 3b plus 3c, and I'm going to rewrite this one underneath it. 12 equals negative 3b plus 3c. All right, I'm adding the bottom 2 equations here. So I've got 12 equals, the b's are gone. What's 3c plus 3c?
6c.
And then divide by 6, we get that c is equal to 2. Couldn't I just go into this one here? Yeah. So 0 equals b plus 2. So b is equal to negative 2. And we're going to write it just the way we did the other one, only we're going to have 3 terms this time. So we said for the a, we're putting in 1. For the b, we are putting in negative 2 over x plus 3. And for the c, we're putting in 2 over x minus 3. So you won't be surprised when you get 3 terms in your homework. Last year they got to be surprised because that example wasn't there. All right, if you look into haiku, I split it into 2 homework assignments. Okay?